Good morning all. So we'll be discussing the slope of the tangent line at a point. So later on we will see how this concept related to our main lesson, which is the derivative of a function at a point. So to start with, let us have a very specific example. So you have here a function f from certain domain to a certain codomain, defined by this function x squared minus 3x. So our goal is to find the slope of the tangent line at x equals 2. So before we solve for the slope of the tangent line at x equals 2, we need first to visualize how does this graph look like. So we will need to graph this function first so that we are able to estimate or calculate, no? So that we will have an idea of what the slope of the tangent line is. So to graph this function, no, we know that this is of second degree, or this is a quadratic function. So it would look like a parabola, no? So it's either facing upward or facing downward, depending on the value of 1 here, no, or a. But in this case, we have 1, so it's going upward. So to facilitate in graphing this function, first we need to find the vertex. Although it's not it's not always the case, but it would be helpful if we know the vertex of the parabola. So to solve the vertex, we have here f of x. No? So to find the vertex of f. So this is the procedure. So we have here f of x equals x squared minus 3x. Of course, we can write it as x squared minus 3x. Okay? And that is the same thing as x squared minus 3x. We know the procedure. We just get the half of 3. So that is 3. We get the half of 3. And then after that, we square it. So that's 3 halves squared. That is 9 over 4. So this is the procedure of completing the square, where that procedure will help us find the vertex of this function. So we need to add this value 9 over 4 here, no? And we subtract also 9 over 4. Now 9 over 4 minus 9 over 4, that is just 0. So we are adding nothing to this quantity here. So it won't change. Now we can regroup these terms. So we have x squared minus 3x plus 9 over 4 minus 9 over 4. So this expression is now equal to x minus 3 halves squared minus 9 over 4. So this is now the form a x minus x squared plus k, where x and k are the coordinate of the vertex of this parabola. So therefore, the vertex of this function is at 3 halves to negative 9 over 4. So the vertex is at here, 3 halves, that is, this is more or less 1.5, and then it is negative 2.25. That's the vertex. Okay? So let's try to plot the vertex. So that's 1.5 somewhere here, and then it's 2.12. That's negative 2.5, so this is negative 2.25. So somewhere here. Okay, so that's the vertex. Since our parabola is opening upward, so we would expect that the graph would look like this. Now, another important information that we can get from the function is we get the zeros of the function. So that is the point on the x-axis where the function f intersects. So how will we find the zeros of the function? Zeros of f. So we need to find the zeros of f, or the roots, no? All these things here will be used to find or to graph this function. So the zeros of f, so we have, we just set f of x equal to 0. We set it to 0 because we wanted to know what value of x or what values of x will make the function 0. So you have here x squared minus 3x equals 0. So by factoring, you have x minus 3 equals 0. So x equals 0, or x minus 3 is equal to 0. So x equals 0, x equals 3. So what does this mean? That means when x is 0, the value of x is also 0. And when x is 3, when x is 3, the value of x is also 0. So where are these points? Okay, this is 0, 0, and that's 3, 0. 1, 2, 3. Okay, so somehow we have visualized already the graph. So what will these functions give us? This will help us make table of values. We have x and then f of x. So we just need probably 6 points or 5. So 1, 2, 3, 4, 5, 6. Okay. So we will first write the vertex at the center. So that's 1.5 and negative 2.25. So that's 1.5. So we can try 1 here. And we need the zeros. So the function is 0. So 0, 1, 1.5, 2, 3. So negative 1, 4. So these points here will give us already the description or the how is the graph of x squared minus 3x look like. Okay. So when x is negative 1, substitute here negative 1. So that's negative 1 squared minus 3 times negative 1. So that is about negative 1 squared minus 3 times negative 1. So that's 1 plus 3, which is 4. So f of negative 1 is 4. Next we have 0. So that's 0 squared minus 3 times 0. So that's 0. Because you know it's 0, 0, 0. Okay. Same with 3. So 0. So 1 is f of 1. So f of 1, that is equal to 1 squared minus 3 times 1. 1 minus 3, that is negative 2. Negative 2. Of course, when you substitute 2 also, it's also negative 2 because that's 2 squared. 2 squared minus 6, that's negative 2. And we have 4. So 4 squared, f of 4, so that's 4 squared minus 3 times 4, 16 minus 12, it is 4. So 4. So if you look at our graph, we see the symmetry from the table of values. So the vertex is negative 2, negative 2, 0, 0, 4, 4. So there is a symmetry. Now let's try to plot those points. So negative 1 and 4, negative 1, 1, 2, 3, 4. So somewhere here. Okay. And then 0, 0, that's right. 1, negative 2. So this is our negative 2. And this is the vertex. So that means this is the lowest point of the parabola. When x is 2, 2 is still negative 2. So here. And then, yeah, this is the root. 4, 4. 1, 2, 3, 4. 4. Okay. So somewhere here. So we have here some points. Of course, we know that there are still points in between here. So we may like connect the points. Okay. And then also here. Okay. So we have now this function. That function. F of x equals x squared minus 3. So this is the graph of x squared minus 3x. It's a smooth curve here. Yeah. This is the vertex. Okay? So we have graphed the function f of x equals x squared minus 3x by finding first the vertex and finding the roots. And we make use of these values in making the table of values for f.